Hi, we're back again for another video. This particular video is for the going over the answers to Logos the Return, a practice internal for 2.2. In here we start off with the function on the left hand side. It is obviously a sinusoidal function, which means it's one of your trig functions. Now if I had to carry that on, it would have come down and then up and so on. So if you look at this point here, the middle point goes through this way. So if you look at this point in here, it is starting at its maximum. If it's starting at its maximum, it tells us that there is a cos function. Next thing you have to do is actually find out where its middle is. Now it's gone from 1 all the way up to 11. So if you want to find the middle of those two numbers, 11 plus 1 all over 2, which is just 12 over 2. So in other words, the middle of those is 6. So that's where it's going through 6. So that is where that number there comes from. Right. Next thing that you want to know is you want to know what this number in the front is. So all you do is you look from the middle. How far up do you go? Hang on, try that again. From the middle, how far up do you go? That distance there. Well, I've gone from 6 all the way up to 11. So it is just 11 minus 6, which equals 5. I'm going to change this pen width a little bit so I'm not quite as messy. Right, so that means that that number there is 5. That's where you've got y equals 5 cos x plus 6. Just goes from minus 9 all the way to 0. Right, the next one that I'm looking at is this function here. It is going up like this. Therefore, what I want, rub that bit there out so I can see it more clearly. Right, what I'm wanting to know is at the moment it crosses, there's my magic point there at 0, 1. So if I go across 1, how much do I go up? I go up 2. So remember, you always start at the crosses the y-axis, so that it hasn't moved left or right. So there's my asymptote. My asymptote is sitting along the x-axis where I'd expect a normal power graph to be, and it has gone up on my y-axis, gone up from the asymptote. It's gone up 1, and it's sitting on my y-axis, so it didn't go left or right. Also, what we have got is we go across 1 from that point and go up 1, 2 from the asymptote. So that tells us that that number here is a 2. Right, then it just goes from minus 1 to 2, where that one there is a closed circle, so it has an equals. Right, this one here is a cubic. It is an S-shaped graph. Just rub out that little bit on the side in here. It is an S-shaped graph. Because of that, we also know that it hasn't gone up and down or crossed anywhere, so we know it's in the form of a perfect cube. So we look at where the point of inflection is, which is this bit here. It's gone across 5 and up 1, 2, which is where you get the across 5 and up 2 from. Okay, that there is the achieved part. Now when you look at the merit part, we'll start off with this function here. It is a hyperbola. You can tell it's got two different branches, and also the fact that you've got some asymptotes. So remember, your key point with a hyperbola is where the asymptotes cross. So the first thing we look at is the equation of the asymptotes. It's moved to the left 1, which is where the plus 1 comes from. It has moved up 1, 2, 3, which is where the plus 3 comes from. Next thing we need to know is we need to know where that number there, the top there, comes from. So what we do is we go from our asymptote here, and then when we go from our asymptote, we go find the one point that we've got. So we go across here 1, and then we've gone up from there. We've gone up 1, 2, 3, 4. So you're going to cross 1, up 4. 4 times 1 is 4, which is where that 4 comes from. Next graph we're going to look at is this absolute value. Absolute value graph normally looks up like that. This one's opposite to that, so it has got a minus in the front. It normally sits on the, let's do this, it normally sits on the asymptote. It normally sits on the origin, which is here, but it's no longer. It's moved across 4 to the left, which is where the +4 comes from, and it's gone up 7, because along here is 7, which is where the +7 comes from. It is switched upside down, like I said before, that's where the minus comes from. Another thing which I would normally do is I would look and go across 1, down 1. Because to go from the next point, going across 1, down 1, I know that there is no other number in the front of here. Right, let's go to our next function. Our last function here is a logarithmic function. It's got its asymptote obviously sitting on 2. So we know that it has moved across, this is interesting, it's moved across 2. Right, the next thing, no, wrong function. It's not that one, it's down here. Right, so we know that it has moved across 2 because there's where the 2 comes from. Next thing we want to do is we find out where that point there is, which is 1 out from your asymptote. You always look across here, and it's sitting on the x-axis, which is what you expect. So the whole lot has not moved up and down at all, which is why there's no number on the end. The next thing you do is you go across until you hit a point. 1, 2, 3, and I go up and I hit the point 1. That means that something to the power of 1 is 3. Well, 3 to the power of 1 is 3. Now that writes it as a bar 3. You should really write it as a little 3 down below. Okay, those are the achieved in the merit questions. Now we start hitting an excellence question here.